Welcome everyone. Welcome to today's webinar. So today we're going to be covering top advantage of surface-based machining. The surface-based machining is our more advanced options for actual 3D surfacing. So the nice part about it is you're actually able to go in and do a lot of surfacing stuff that you're not normally able to do. Now it's not saying that some of this examples I'm going to show you today can't be done with other toolpaths, but they're actually designed to showcase what is awesome about these toolpaths, the extra options, the little things that you can do with them. Now, a few of the things that we actually go into today with them, and the first one I always point out that's kind of the big one, is these toolpaths actually allow you to go in and actually do a undercut. So it'll actually do true undercutting for you, okay? So let's go ahead and just start off with the slideshow portion first, and then we'll just kind of go on from there. All right, basically we're just going to be covering strategies for machining, tough to cut areas of the part, how to improve overall surface finish qualities. We're going to do surface-based versus other toolpaths. So I'm going to try to bring in some examples where I can show you what the differences are between the toolpaths. The tool control, undercutting, gouge checking strategies, and complex 3D machining advantages. More control over the toolpath output. Control what surfaces you are machining without needing to boundary off the area. Gouge checking allows you to check surfaces for collisions with the tool. So kind of a couple of things that we'll be covering is the ability to go in and use gouge checking. Okay, so it actually allows you to go in, check surfaces, you're able to check clamps, those type of things if you actually have the models drawn. So what we're going to do here is we're actually going to go ahead on to the next one. Links. One of the big things about the actual surface ability toolpaths, they actually have different linkage options. These toolpaths actually allow you to control, as you can see from the image, small gaps, large gaps, links between slices, small moves and large moves. So you actually get to customize the way it outputs and actually choose the parameters which fit you the best. Okay, on small gaps, I want it to go straight across. I don't want it to actually like drop down in, those type of options. Now what's going to happen to this point, you're going to go to the undercutting option. Okay, basically these are the only toolpaths that will crisscross themselves. All right, the nice part about it, you can actually go ahead yourself, and once you go in, you have your special types of options. In the turning, it refers to the recess of everything. So what's nice about the undercut is it's the only toolpath that will actually crisscross over itself. Okay, the nice part about that is you can actually go ahead and go in there, and if you look at this image, it actually will cross itself back over and come back down and around. Okay, the gouge checking, again, just covering the gouge checks, how they actually work. In these particular options, you actually have a lot of different options on how it can gouge check, what it actually does. And basically, it just allows you guys on those surfaces that, you know, maybe you're going down into an area where the tool and the holder might collide with the wall, but you still want to use that particular tool. You're able to check it off. And what it'll do is it'll actually force the toolpath to morph to what it needs to be to actually properly output it. Now, when we're going through this, if you do have any questions about what we are covering, please just go ahead, chat away. If you have any questions about anything else pertaining to BobCAD, shoot those as an email, okay? That makes it easy on us because then we have a reference to go back to actually pull those up. But if you do have any questions about what we're covering, just go ahead and let us know. All right, so what I'm going to do now is I'm going to go ahead and flip us over to monitor number 2, and you guys should actually be able to see all of the actual parts. So we have a few different parts. These are just basic parts to kind of cover some of the things that we're going through. So let's go ahead and dive on in to the actual portion. I'm hoping that some of you have already actually used BobCAD version 29. That way we can just cover what we need to on the advanced surfacing. So in this particular case, we're going to go ahead and blank out this job, and we'll just do a fresh job for ourselves. So a part like this, okay, we're going to go ahead and do a toolpath versus toolpath, okay? So if I just had our typical surfacing option, I would go in to the job, create the job, so we'd set everything up. All right. Okay. And what we're going to actually do is we're just going to do solid model stock for this one. Okay. Pick the solid model. All right. There we go. Okay. Now, once you have that set, we're going to go in here, right-click on Machine Setup. What we'll do first is we're going to start off with a 3-axis toolpath, right? So you would go in, and not saying these toolpaths aren't great. This is just a tough surface to actually get a proper toolpath. So when I go down in here, I'm going to select the model. I'm going to hit Next. And what I'm going to do is I'm actually going to go down to the strategy, and I'm going to use the equidistant and the planar. We'll do advanced planar, though. We won't do the regular planar. Okay? By choosing these options, we're going to go in, define the ball mill we want to use. Okay? Patterns, parameters. You have your step over. We're going to leave it at a pretty basic function. We're just going to leave the same step over. And then we're going to do the same for the planar. The only thing we're going to have to change on the planar is going to be the lace angle. So in the actual planar, you change the lace angle to get it to go in the direction that it's not currently going. I'm going to go ahead now and hit compute, and let's take a look at what both toolpaths do, and then we'll go ahead and compare them to what's already done with the actual morph options. Okay. So what's going to happen is we're going to go ahead and take a look at the planar. Okay. So we're going to blank out the equidistant first. Okay. So there's the advanced planar. The first thing you're going to notice is no matter even if I change the actual toolpath a step over, you're going to have these. Okay. Where the toolpath is coming, going up, going over, coming back down, because it's a projection down on the part, right? Equidistant does a better job, right? If we blank it out, we actually have the equidistant, which is doing a nicer job going this way, right? But we might need to boundary it to only be in that particular area, which you can. But it'll actually follow the true surfaceability. That's why you have a nicer toolpath output, right? But I just really want to cut this area here, and I really just want it to be back and forth, back and forth. Well, guess what? You can do that with the actual advanced option. So let's throw an advanced option on there. Let's go down here to the mill multi-axis. Now I know what you're thinking, mill multi-axis, meaning 4 and 5. Yes, they are part of those toolpaths, but they do output as 3, so don't let that deter you away. So we'll go down here and we'll actually choose parallel to multiple curves. Right here. We're going to hit next, and we're going to go through and define our settings. Again, we're just going to use a ball mill for right now. We might change them to a lollipop cutter to get the rest of it, but we will go ahead and see. All right, so if we hit next, we will go down here to the edge curve, and all we're going to do is just pick that top edge right there, like so. Come on. Oh, I keep picking the back. Okay. There we go. There's our edge curve. Right-click OK. And then what we're going to do is we're going to go down to the drive surface, and we're going to pick these two. Right-click OK. Now, as you can already tell on the parameter page alone, you actually have a lot more options that you normally wouldn't have. Down here, you have a cuss pipe. and a step over. So if you know what your cusp height needs to be, you can type it in and it'll give you the proper step over. Okay. Now, once you have all that stuff defined, we're going to go over these in a few. Let's just go down here to the actual output. We need to switch this to 3-axis output. On the next page is your gouge checking options that we were talking about, where you can actually go in and check everything, and we'll cover some of those as well. And then again, your linkage. Now, the big difference is down here, if you notice the next button doesn't turn on, it's because all the things are up on tabs up here. So we're going to go ahead and hit compute. Let's see what we get, and then we will adjust the toolpath as needed. Now, these particular toolpaths, there's a lot of different settings that can alter the toolpath. Normally, what I try to do is try to get a baseline toolpath that looks somewhat right, and then I alter it from there. Okay. So as we can see there, I mean, that's not bad toolpath right there. There's a lot of rapids. So to fix those rapids, we can actually turn on zigzag. Okay. So we're going to go down here. Let's turn on the zigzag feature so we're kind of matching the rest of the toolpaths we've already started with. All right. Down here under the one-way cutting, we want to choose zigzag. Let's hit compute and see what that does. There you go. Okay. Now you still have the rapids, obviously, from here. These are just because the tool is coming this way, and it doesn't continue on along it. Okay. So what you're able to actually do with those, okay, these would be considered retracts. You can go into that actual option. So on a normal toolpath, if that's what you got, that's what you got. There was nothing you could do about it. These toolpaths, you can go in and eliminate a lot of those. So you go down in here into the linkage side, and you say, cool, let's go ahead and links between slice. We don't want to retract. We just want to do a direct. What that does is that alters those options to just basically go straight to the next one and continue on. Wait for it. All right. So these ones here are actual. There you go, right there. Okay. So those are now just direct. They go one to the next. And now we can work on the main ones. So let's go back in there. And let's go over some of the stuff on the linkage page while we're here. So you have the entry, first entry, last entry, use lead in, use lead out. You have gaps for small, okay? You have direct, follow surface, blend spline, step, and then you have the rapid options. Link between slices, they all have the same options too, direct, blend spline, all that stuff. So if we go here and we say, okay, let's do a follow surface, right? We can then go ahead and you can actually customize the small gap size by a percentage, or you can enter a value. That's what alters and determines whether it's a small gap versus a larger gap. So if I hit compute, let's take a look at it. There we go. So if you look now, it'll actually go ahead and it reduce the rapids to follow the actual surface and continuously cut around. Now, pretty neat feature as well is the ability in the new version 29, and this is just a side note, we have the ability to backplot a tool in here. So you can actually turn it on, have a tool come in here, and actually be live on the piece. All right, so we're going to speed this up just a little bit more. And you guys are able to watch it. So as you can see, the surface quality is different. This one is following more of the contour of the surface, as opposed to me having to do a bunch of different steps to really get it contained and get a decent tool path and all that stuff. You can actually use these to your advantage in those aspects, okay? Okay, so now the next thing would be turning on gouge check and making sure that the gouge check worked properly the way we wanted it to, right? So how the gouge check actually works to help you guys is in the actual parameter side. You guys go into the gouge check, you guys just turn it on, and then you get to choose flute, shaft, arbor, and holder, right? You then say, okay, do we want to retract tool, trim and relink, stop calculation, or report the collision. So you have 4 different options to get the data you need. Okay. You then have drive surface, check surface, and then you have a long tool axis. We want to go Z or tool plane. And then you even have advanced options that allow you to go drop tool down whenever needed, smooth retracts, and you can set up the smooth distance to smooth out the retracts. Now, if I go in here myself and I say, okay, let's check the surface. Let's just check this surface here, just because this surface here, I think the tool holder might catch it if the tool is not long enough. So let's just turn it on. And then when you hit compute, you might see a slight adjustment to your tool path to compensate since we have everything turned on. It does increase the calculation time of your tool path because now it has to run those checks and refigure out the path that's going to travel. Okay? So because of that, as you can see here, right, with us turning that on, the way the tool holder is colliding, it wants to go ahead and jump the tool path around in a bunch of different ways so that it doesn't collide with this face, right? So that tells us one of 2 things. We can either go in, turn down some of the collision checking, right? So we could go into the Gouge checking and maybe shut off the actual arbor and shaft, okay? Or we can use a different tool, okay? So it just depends on how we want to alter this. So if I just turn on, tool and shaft, and I hit compute again, it'll probably give us an average tool path. But what's happening is because that tool holder is so big and this gap isn't that long, it's going to catch it in certain areas as it continues down further and further. So it's retracting away so we can get what we need. Okay, so that's a better tool path there. Obviously with this, it's making sure that it's not just doing the straight around cuts. So we're going to go ahead and go in there and shut the next piece on. All right, so on this particular part, we're not going to need the Gouge check. It'll be totally fine. And I'll actually show you guys a really good example with Gouge check so you guys can really see how the Gouge check really does affect your parts. All right, okay. So let's move on to another part now. Obviously, we have all that data there. As you guys can tell, all options change the way the output does. Now, another interesting one before we continue on here. Some of your tool paths will always stop at the edge of the surface. Well, let's just say we want to extend these tool paths. All you actually have to do to extend the tool path, some softwares you have to extend the surface, some tool path options you have to extend the surface. This particular one, you just go into the extend and trim, turn it on. You can do percentages or you can do a direct value. So I could say 1 inch, 1 inch. Okay. What it's going to do is it's going to extend the tool path out following the surface without me having to do any extra moves. Boom. See? So we extended, and this extended these ones here, so it still has to wrap it because these are the next parts, but that's actually extending the start and the ends of the tool path as it comes across the contour. But there you go. There's your extend and end. As easy as that, you guys can output your actual extend options. Now, let's dive into another part. These are a lot of these parts. I use a lot of the morph between 2 curves and stuff like that. This one's really good. This one showcases, following a nice steady continuous around, right? Going down as you're cutting, stepping out a little bit further past the surface. Another example, just so you guys can see, just different options. Here, cutting some fillets around this. So let's go ahead and do that so you guys can kind of see the particular scenario. I mean, cutting around a part with a fillet doesn't seem like it would be extremely difficult, but there are scenarios where it is. So we already can see that that one's cutting just fine, and that's actually a morph between 2 surfaces. That's selecting the bottom surfaces around and the top surfaces up top, just so you can see. So morph between 2 surfaces. In this particular case, you have the drive surface as being the fillet all the way around, okay? You have a one-way cut direction, and then you have your step over percentage here. And then under tool axis control, it is set to 3 axis. And then you have gouge check, linkage, and the linkages are just set to the basic standard, okay? So what's kind of neat with these particular scenarios with this, if we go in and we add in a 3-axis cut, let's just go ahead. We're only going to select this surface. Okay. So we pick that all the way around, right-click OK. We hit next. We go in here, we choose rapid. We're going to go ahead and use equidistance, probably going to be the best option to try to get a nice little output on it. Go in, we'll set the step over, that's fine. Leads, and we'll hit compute. Let's take a look at what it does first, and then we can go in and change some stuff in the equidistant. Because what you're going to run into is it's probably going to cut more than we want, so we're going to try to boundary it. But when we try to boundary it, it's not going to cut all the way down the edges, because then we have a boundary now stopping the tool from being able to cross. Now you can go in and alter it going past it. So let's go ahead and take a look at it. Let's shut off the previous toolpath. So we're going to blank that one out for us. And there you go. So see how it's not actually, if we turn this one, let's change the color of this one to blue. There's that one. And then here is the multi-axis. See how it's actually going down the full surface? It's following the contour all the way up, and it's giving it that extra couple of passes. Now you can go into equidistant and mess with that to get a different output, but I don't have to do anything special with that one. I literally would just have to pick the top surface back and then just the surfaces around, and it would calculate it all the way around. Okay. All right, and you can also see it starts to separate just a little bit over here, shrinks up a little bit here, goes a little bit bigger here, and then you actually have, on this one, it's a continuous, nice, smooth transition. Okay, so that's another example of just being able to use that particular toolpath in those aspects. So as you can tell, there are certain scenarios. Now some of these are, like I said, pretty simple scenarios, but just being able to actually go in and use different toolpaths, parallel to multiple cuts, surface-based, they're just nice little examples, right? Okay. Now, okay, cuts along a curve, taking a simple surface. A very interesting one that has recently been released is Flowline. So a lot of these, you're going in, you're picking multiple different edges, and you're picking the surface between them, right? And it's not a lot of steps, but it's still steps. What we did is there's actually a toolpath called Flowline, okay? So what we're going to do is we're going to go ahead and introduce that one right now. So I'm going to go ahead and just grab us a file for that. So bear with me for just 1 second while I grab that file. All right. Okay. So this is actually a nice example. It is a solid single surface. That's what the Flowline has to have. It has to be one surface. Okay. So let's do our setup on this. I'm just going to set this thing up for us. Now, what's nice about this Flowline particular toolpath is you can select this, select your boundary. But Flowline, on the other hand, when you go in here to the multi-axis, Flowline is the very last option on the bottom. Once you pick Flowline, you will then hit next, go through and define your tooling. So we're going to say we're going to use 1/4 inch ball. Then we're going to go to the parameters. So like the other ones had different options. First curve, second curve, drive surface. This one just has a drive surface. Pick the single surface. Right click OK. And what you do is you make sure you go in and you turn it to 3-axis, which is fine. And we're not going to worry about the gouge checks, linkage. We're not going to have to use any of those on this particular part. But watch this. So naturally, I always let it calculate first to determine if I need to switch the direction in which it goes. There you go. So it creates a toolpath all the way across. Now it rapids back. It's going in the exact direction I need it to go to. But you see how, like, one click on that surface, I have a surface toolpath that is usable. That'll give me produce a nice scallops going in the same direction piece. So if I want to, I can go in, and again, these rapids are all due to messing with the linkage settings. You can go in. So first thing I always check is if I wanted to do like a zigzag, I can. See what the zigzag does. Does it eliminate most of them? Okay, cool. Then those are actual retracts. So I need to go in and set the retract option in the linkage. There you go. There they are. So these ones we still have. We can go in here and make these direct, okay, as opposed to rapiding up to the retract height. But look at that. Just one click and I have a surface-based toolpath. No having to modify geometry, no added information needed, just surface, tool, step over. That's what's nice about those toolpaths is they allow you to get in there where you normally can't and output what you really need. All right. So what we're going to do here is we're going to go ahead and I'll show you another example, right? So these just have cutouts here, but what happens if the cutout is in the center? So watch this. If I go File, Merge, I'm going to bring in the same exact file, but it actually has a cutout in it. Switch to my SolidWorks PRT. This is also a neat trick, guys. If you're ever programming a part and you have to bring in another version of the model or something has been changed on the model, you can always file merge it. It brings the other file in. What I normally will do is just delete out this one. And I have the new model. And all I have to do is just go in here to the geometry, select it, recompute, and update it. So you guys can file merge. What I'll do too sometimes is I'll put a layer, put one of the files on a layer down here. That way if I need to modify anything, because I'm only changing maybe one or two toolpaths depending on the change. So why change all of them? I have to restart, do all that stuff. You can just file merge and just select it off anew. And there you go. Even with this, it's still wrapping up, which is fine. Again, you can adjust those type of things. But it even takes into account this, and it continues on. It keeps cutting, it keeps going, it doesn't stop. It stays in the same direction, and it just flows across the surface. All right. Now, if you have any questions on any of that, go ahead and type those away. It looks like we're having a few questions pop up. Okay. So the question is, will these files be available? We can make them available if needed. Yes, this will be a recording. As usual, we're going to record this. It is being recorded right now. So that way, it will be available online for you guys to actually go back and review. Because a lot of these there's a lot of different settings in these particular ones that can alter how the toolpath outputs. I mean, you have options like, you know, as easy as flipping the step over. So if it's cut in one direction, you want it to start from the other way, you just hit flip step over. It flips it to the other side. You also have an option to control, and this is a kind of a neat feature. Say you wanted to limit the number of cuts. You can actually go down here and say, because right now I have full avoid cuts, or avoid cuts to exact edge, and then you have full start and end of exact edge surface edges, so it cuts right to the edges. Then you have determine the number of cuts, and this one you can actually just go and say, I want 5. Watch this. It's only going to put 5 cuts on the part. So you guys can actually go in and limit it. You can use these toolpaths and then control how far it steps over. There's 5 cuts. That's it. Nothing else. Just 5. So you can actually control, limit, you know, set up the way you want to, and you can fully define these toolpaths to be what you need. So you have a surface there, you pick the surface, you pick the edges, whatever you decide, you can go in and you can control it. You can limit between 2 points. You can actually draw 2 points on the screen, pick the 2 points, and there's only toolpaths between the 2 points across the surface, of course. Now, the other nice side with it is with these toolpaths, all of them also have the one-way, zigzag, and spiral option, and they also have start point controls where you can actually pick a start point for them to start from. Okay, you have machine by lines or by region. What that allows you to do is if you have multiple surfaces selected in some of the other ones, and there are gaps, it'll break them down into regions, going region 1, region 2, and then region 3. I always just say, do it all. And it cuts all across them, and then I can control how it goes from this surface to that surface. But if you don't want to do that, you can control it by region, so it focuses on the regions first, and then it'll move on to the next portion as well. Now, let's go ahead, and let's bring in the actual undercut, okay? So some of the scenarios that you run into with the actual undercutting option, okay, is you actually go ahead and you have different options with the undercut. So give me 1 second. Okay. So we actually have another few questions here. So here's the actual undercut I'm talking about. So okay, so the question is, would you use these toolpaths basically to rough out the excess stock? Those particular toolpaths, when you actually go into them, just so you guys can see, when you have toolpaths like this, if you want to use them as a roughing toolpath to follow it, you guys can actually go in and do multiple depths of cut with them. Under the parameters tab, there's an option called roughing. When you go to the roughing, there's multiple passes and depth of cuts. So if I go in and say, let's do depth of cuts, I could say, okay, I want 20 of these, and the spacing is going to be 1/8 of an inch, for example. I can say hold toolpath, hit compute, and watch this. So you guys can use these as roughing passes if you wanted to. It's just going to follow the contour, so you're going to get this, where it follows the contour, it does 20 passes. So if you want to do multiple passes, even if it's 1, 2, or 3 passes stepping down just to have a nicer surface finish, you are more than welcome to go in and alter that so it outputs the way you want it to. Now, let's jump into the actual undercut on 3-axis. So this is a great scenario. You know, it has an undercut here. Basically, first, there is just the advanced rough, okay? Just your typical 3-axis advanced rough, roughing out the excess material. So we're going to blank that one out. We're not going to cover the advanced rough. So let's go ahead in here and check out all the settings that we use to do the undercut, okay? So to go in and do it, the drive surface, if I blink out the stock so you guys can see it a little better, if I click on drive surface, the drive surface is obviously this surface here where the actual undercut occurs. Now to set up the undercut, the first edge is the top, second edge right here. So this is an actual morph between two curves. Now the gouge check surface are the two surfaces here, so the tool doesn't collide with it, okay? So if we go into the actual settings on the piece, this is actually a morph between two curves. It is using a lollipop cutter, okay? So the nice part is you have the different abilities and options to turn on those particular settings. Use those tools as well. Then we're going to hit next. And we have the option to go in and choose our settings. This one actually has the extend trim on as well, where it extends the toolpath past the start and end surface. And that way we can actually go ahead and go through all the different settings on that. Now what's nice is after that, if you look down here, you just have your maximum step over. We're going to hit next or go to tool axis control. 3-axis is turned on. And then you guys have the gouge check on. And you have the tool in the shaft, so that way it doesn't collide with the walls and everything. So you guys can go in, do those particular settings, and set it up exactly the way you want it to be so it doesn't collide with anything, so you're golden at that point. Okay. Then if I go ahead and I choose my linkage, if you look, these are set just to the stock ones that were defined, direct, and retract. So you can go ahead and set those as well. You can change those around and do what you need to with those particular ones. And then in the roughing option, nothing is changed in here. So when you hit compute, you actually get the undercut. And what I'm trying to point out on this is if you look, the toolpath starts out over here over itself, comes down into it, and crosses itself going down. So that's what I talk about when it actually will cross itself. The other 3-axis, like equidistant, you can't get the toolpath to do that because it won't cross itself. It stops the calculation. These ones are actually designed to go back and forth across each other, so that way you can actually get your true undercut out. Now just so you guys can actually see this, let's launch the software simulator so you can actually see how this thing works and it's running. And we'll go ahead and hit play, slow down, so you guys can actually see it. There it is, just roughing out. You know, you can't get much better than advanced rough. It's a really, really nice roughing toolpath for you guys to use. It does everything it needs to. Okay. So as you can see, it's just stepping down. It's doing just the normal roughing toolpath. Okay. Now a couple things too. If you're new to BobCAD and you've never seen the actual option to just skip ahead, there's a next op which jumps right to the next op for you. So that way you can just focus on what you're looking for. We're going to turn the stock a little bit transparent so you guys can actually see the ball cutting through. And then we are just going to go ahead and let it rip through it. Okay. And it's just making it step down each pass, going down, down, down. There you go. Now if you want to see what's actually going on, you can turn on your workpiece versus your stock, and you can see we're cutting the size here, and it's still removing all this material coming up over there, and that way you guys can go in here. All right. And that's how you actually do undercutting. So if you have jobs where you actually have to output a true undercut, you're going to need the advanced options to achieve what you're looking for. That way you guys can actually do what you need to. Okay? So now let's exit out of here. Let's go ahead and go back in. There's a couple things we're going to cover before we wrap up for the day. What we're going to cover is the options in the Utilities tab. Okay? As you guys saw when we went into the actual roughing option, you can see a lot of different options. Okay? Stock definition is just the ability for you guys to bring in an STL file, kind of like trim to stock options that we have in the 3-axis. That's where this originally came from. So you bring in an STL file of stock of already previously cut material, you tell it what it is, and it'll go ahead and do it. Multiple passes speaks for itself. It just does multiple depths of cut. Same with depth of cut is the same thing. Depth of cut goes straight down, multiple passes, follows the contour of everything, and that way you actually get what you're looking for. Plunge cutting is used just like, and you would just use 3-axis plunge cutting. You wouldn't use it in this aspect. You would. This is so multi-axis could have a plunge cutting, where it just plunges your tool straight down into the part. You pick the length and the step over, and that way it just keeps plunging down, removing the material. Morph pocket is the ability to select a boundary and just tell it to morph pocket it. So whatever you select, you can actually say, okay, we'll morph from center out, inside out, outside in, what's the step over value, and is it a full pocket or by number of cuts? It's just allowing you to turn a toolpath into more of a pocketing toolpath, depending on what you're trying to do with that particular selection of geometry. And you also have a spiral machining for it that turns it into an actual spiral. Area roughing is used a lot on the turbine blades. It allows you to actually go in and control how the actual roughing passes go, calculated based on the tool engagement across the surface. Instead of just having a couple tool paths, you can actually control how it does the multiple step or the maximum step over it creates. It just transforms the tool path. Like I said, again, it's used a lot. We use it on turbines. Transform and rotate just allows you to transform the tool path and rotate it around if there's multiple different surfaces that you're trying to engage with the same settings. Mirroring is a new option. It actually allows you guys to mirror toolpath. What's great about it is you have a mold cavity. You have the mirrored side on one side, the regular side on the other. Instead of you guys having to program both sides, you could just hit the mirror option with these toolpaths, and you tell it the plane and everything, and you can actually go ahead and define it, and it mirrors the toolpath from one side to the other, so you no longer have to go in and create two completely separate features to go ahead and do the mirrored opportunities. Okay? And then sorting option just allows you to sort the passes and everything, how it's done. Is it done by area, by region? How do you want to cut them? Which one do you want to go to? You can reverse, by passes, complete tool path. So it goes 1, 2, 3, 1, 2, 3, 1, 2, 3, or 3, 2, 1, 3, 2, 1, 3, 2, 1, depending on if we want to start higher or go down those options. Some of these you wouldn't actually use on 3-axis just because they're meant more for the multi-side, but there are some like mirror, depths of cut, the multiple passes. You can use the morph pocket if you want to, you can use. And that's pretty much the most out of that one that you guys would use. Then the utility tab as well. These are just little options to control the toolpath. The actual shifts and stuff, you're not going to mess with these. That's multi-axis again. But in here you have like a feed control zone where you guys can actually draw and select a piece of geometry on the piece. And it would control the feed rate differently in that one. So it'll actually like crank up the feed rate or slow it down in that area. And then as soon as it exits the geometry that you've selected for the feed control zone, it'll actually go ahead and speed back up. So there are little options like that that you guys can go in and actually use different controls for that. And then use rapid feed rate. It allows you to control how the rapid is and everything like that as well. All right. So that's going to take it through a brief introduction into what we can actually do with the multi-axis options. You do have multiple different options you can choose from. You can actually go ahead yourself. And if you have any other questions or more info you're looking into on this, go ahead and just contact us and let us know. If there's anything else we can do for you as well. If you're not sure and you have a part you want to know if the multi-axis can help you with some of the machining on it, get it over to us. We can take a look at it, and then we can actually show you what the toolpaths do on your particular part. That's usually how I like to do that, is so you guys can actually see it on something that you've already programmed. It's not exactly the way you wanted it to be. You would like to have an easier solution than using 14 different toolpaths. Some of those will actually cut down on how long it takes you to program. So again, I really appreciate you guys coming into this week. We are working on the next webinar. If you do have suggestions, they were asking on Facebook for suggestions and everything like that. So we're going to go ahead, get this recording out to you guys within the next few days. That way you guys can start playing with it. If you are playing with it and you do have questions, again, all you have to do is contact us, and we will go ahead and help you through it. Thanks, guys.